Hey everybody, so today, as promised, we're going to implement these stacks, decks, and queues. I'm going to be doing it a little different today. So these, we're not going to do a code walkthrough at the end. You know how I usually go through, knock out the code, and then we go through some Notion notes. We're not going to do that because these are very simple data structures. We're going to implement them entirely using Rust built-ins. So you'll get to see some of these the Rust functionality that's built in, and yeah, they're quite easy. You guys should have no problem following along with this and understanding what's going on. The trick about these guys, like I said in the theory video, it's about knowing which one to use when, and not overdoing it, and not using decks everywhere, or using a queue when a stack will suffice. Like, that's what it's really about. Okay, but we're going to go through and I'm going to show you how easy these things are to do in Rust. Okay, or just in general, any programming languages are quite easy to implement. Implementation. All right, guys, let's get started with the stack. All right. And then we're going to implement them as the shape is going to be that of just a vector. All right. Now remember, stacks. We are only dealing with the top node, right? That's the only thing that we care about in a stack, is the top. These are last in, first out data structures, okay? So, simple on it. All right. Yeah. And then new vector. Okay, now, so what do we need? Okay, so so across the board, all of these, you need a way to peek at the nodes of most concern. You need a length, and you need to check for emptiness. Those are kind of the three methods that we're going to implement across all three. Now, specifically for stack, it's very simple, right? So you just need a push. And a pop. And this is going to return an option. Okay. And as you see, Rust takes care of all the heavy lifting here for us, right? For this, as it will do for all the other ones. Okay. So now we need to do a peek, right, where we are concerned about the top. Now, for this, guys, so when we print these out, okay, when we print these out, okay, so say that we push 1, 3, 5, and 7, okay, when you look at these, you look at them like this, right? You look at a stack in a vertical position, not a horizontal one, right? So when we do this, it's going to be 7, 5, 3, 1. Right? So you take that array or that vector or whatever, and you flip it this way. Okay, so that the bottom is on the top. So when we peek, we don't want to peek at the front, we want to peek at the back, right? Because that is the back of the array. We're just making it the top to form a stack, right? So self.items. Is it last? It is last. So this will give us the right thing. Okay. Now, these are the common ones. Link, and then we'll do is empty. Actually, sorry, got them mixed up. That's the usize. This one's the boolean. And then self.items is empty. Right, and that's it. That's it, guys. Put that up. All right, so that's it for a stack. Right, pretty easy to get going there. I'm actually going to dump it back down. All right, now let's do our queue. All right. I want to separate these out. That way you guys can see each one clearly. Okay. Now here, these are going to be implemented as we talked about in the theory video with a vec deck. Okay, this gives us a double-ended queue. Now, queues. We push to the back and we pop from the front, right? Like a line in a cafe. New people come in the back behind the person that was before them, right? First come, first serve. Right, so this is a first in, last out. First in, first out data structure, right? And yeah, so well, let's implement on it. Queue. All right. And this is going to be a vec deck. New. All right, now. So here, right, we're adding elements to the back, we're removing them from the front, and so we're concerned about the front and the back here, right? So we're going to do a peak at the front and a peak at the back. And then, of course, the usual lengthen is empty, all right? And we have to we need to push to the back and pop from the front. All right, so let's do that first, right? So we're going to push to the back, all right? And this is going to be dot push back. Look at that, handy, huh? Handy. Told you, Russ is taking care of pretty much everything for us here. Pop front, okay? Yeah, got to do that. Now, self.items dot pop front, okay? Then we'll do pub fn. We'll go ahead and do our length. Just knock that out. Okay, and then is empty. Go ahead and do that one. Now, let's do our peak, right? We need to peak back. This will give us a reference. And then items dot back. Right, and now fn peak front. Self dot items, guess what? Front. And that's our queue, guys. Like I said, these things are very easy. Very easy. Alright, now let's do our deck. Alright. Once again, these will be implemented with a vec deck. Alright, now, decks. We can push and pop from both sides, right? So, okay, and then, as before, there we go. All right, now, let's go ahead and just knock out some method signatures here, right? So let's do, we'll do pop front. Okay, now we'll do pop back. Then we'll do push front. And we will do push back. save some time, since we're using the same naming conventions, we'll go ahead and we can just pop these down here. Right? Okay. Now, so what do you think the magical Rust method is for this? Self.items.popFront. Right. Then we got self.items.popBack. Self.items.pushback. We need our values for this, or our item. Oh, did I lose you? Yep, lost you. Still happening, guys. That thing is still doing that. And then self.items. Push front, push back. Item T item. Alright, then the last thing we need is our peaks. Right, so pub fn peak front. This will return a reference because the whole idea here is that we're not moving anything. We just want to be able to peek at the value at the nodes we care about. Right. Now, self.items.back and self.items.front. That's it, guys. That's it. We got it. Right? So, let's go over here to main. Oh, well, actually, one thing, guys, I want to make sure that we're correct here. So the thing is so with queues, we don't call them this. The actual appropriate name is NQ and DQ. So I'm just going to call this NQ like that, and I'm going to call this DQ like that. Okay? Yeah, that's just the terminology that's used for queues. Okay? And so now I'm going to go over here to main. I did a little main implementation just so that we can see the functionality real quick. And actually, I want to open these up in a, well, actually, no, I'll just do them in my IDE. That's fine. That's fine. We'll just run them here. No, because I want to be able to show, them next to each other. All right, so, Alright, so here we go. Okay, so alright, so here we go. Make sure this is big enough for y'all. There we go. Okay, so you will see for our stack. Okay, so our stack is here. Alright, so well, it's here, right? So we push 1, 3, 5, 7, right? 1, 3, 5, 7, and then we get a stack count of 4, okay? Then we peek at the top, right? Our top here, remember, 7's on the top, not 1. 7, 5, 3, 1. So we peek at the top, we get 7 back, and then we go ahead and pop 7, which removes it. The peek doesn't remove it, the pop does, and then we see 1, 3, 5, and then the stack is empty is false, right? All right, then for our queue, right, so we're queuing up 1, 3, 5, 7, and then returning a queue count of 4. All right, so we're going to peek at the front, 1, peek at the back, 7, then we pop from the front, which we're supposed to do, right? Get 3, 5, 7, the queue is not empty. Now, we go into Deque. So with Deque, we have 1, 3, 5, right, with a count of 3, and then we peek at the front, right, we get 3, it's still there. We peek at the back, 7, it's still there. Then we pop the front, 1, 5, 7, and then we pop the back, 7. We ended up with 1 and 5, the middle values, and the Deque is false. So that's it, guys. Pretty simple, right? As I said, Rust does all the heavy lifting here for us. It's really about knowing when to use these things. So yeah, guys. So if you have any questions, hit me up. Help each other out in the comments. Ask respectable questions, get respectable answers. And hey, have a good holiday, whatever you call it, and be safe out there. The traveling is crazy right now with all this ridiculousness that's going on. So yeah, guys, you guys be safe out there, and yeah, I'll see you guys after the break. Appreciate you.